All right, this is the practice 7.7 through 8.1 test. And as always, I am the amazing Mr. Jansen. So away we go. If we take a look at this first one, really the only difference between this and what we've already done in this course is the notation. This f plus g of x, remember that this means the same thing as f of x plus g of x. It's just telling us that I want to add these two functions together. F of x is the x squared minus 2x plus 2, and the g of x is the x plus 3. And since I'm just adding these together, I don't need the parentheses. I can get rid of them. I can ignore them. And I'm just going to combine like terms. The negative 2x and the plus 1x, the 2 and the 3. I combine like terms. I get x squared minus x plus 5. And that's it. All right. For the next one, very similar. This one, again, the function notation means I'm subtracting these two functions. So I'm going to do f of x minus g of x. So when I do this, I'm going to have the x squared minus 2x plus 2 minus the x plus 3. For this one, I could just subtract like terms. I'm going to distribute the negative to make sure I don't make any sign errors. So it's going to be an x squared minus 2x plus 2 minus x minus 3. And now I'm going to combine like terms. And when I do that, I get x squared minus 3x minus 1. And that's it. All right. We distribute the negative and combine like terms. Again, it's just like adding and subtracting polynomials. The only thing that's different is the notation. For the next one, notice in here that this is a closed dot. That means multiplication. That's our multiplication symbol. Again, this notation means that I want f of x times g of x. I just want to multiply the two functions together. So that means I'm going to have x squared plus x minus 5 times the x plus 4. And when I do this, I just want to distribute, and you can either distribute the first polynomial into the second or the second into the first. I'm going to work forwards. So I'm going to distribute the x squared. That's going to give me an x to the third. I should give myself a little bit more space here. X to the third plus 4x squared. And now I'm going to distribute the x. That's going to give me a plus x squared plus 4x. And then lastly, I'm going to distribute the negative 5. So that's going to give me a negative 5x minus 20. And now I just combine like terms. Again, this is no different from what we've done many times in the past. The only thing that's different is the notation. So x cubed plus 5x squared minus 1x minus 20. And that's it. For this one, we've got f divided by g of x. Again, the notation means f of x divided by g of x. So now I'm dividing each of these. F of x is the x squared plus x minus 5. The g of x is the x plus 4. And now there's two ways I can try dividing this. Well, really three when it comes down to it. The first way, the easiest option, if it works, is to factor. So I build a bridge, I get a negative 5. Two numbers that multiply together to give me a negative 5, but add together to give me a positive 1x. It's not going to happen, okay? So I can't factor this. If I could have factored it, I'd factor it and then cancel out any common factors. Since I can't factor, I can either do long division or synthetic division. Since the thing I'm dividing by is a binomial of the first degree with a leading coefficient of 1, I'm going to do synthetic division. So I'm going to take the opposite of this guy right here, and I'm going to put it in my box. So I've got a negative 4. Now I write down my coefficients of the thing that's being divided, which is the x squared plus x minus 1. So the coefficients are 1, 1, and negative 5. I bring down the first coefficient. I get a 1, and now I multiply negative 4 times 1 is a negative 4. I add straight down, that's a negative 3. I multiply negative 4 times negative 3 is a positive 12. Now I add straight down, that's a positive 7. And here's where I get out my secret decoder ring. Since the thing I had originally was an x squared, and I divided it by an x to the first, that means I'm going to start my new my answer with an x to the first. So this is a 1x to the first minus 3 plus 7's the remainder. Remember, the remainder I always write over the thing I was dividing by. Okay, so that's what it looks like after I do my division. All right. For this next one, I've got f of g of 3. And since I have f of g of 3 here, I'm going to rewrite in the other notation. That really just means f of g of 3. And when I do this, I'm just going to start inside the parentheses with the g of 3. I'm going to take that off to the side. G of 3, well, g of x would be x squared, but instead of x right here, I'm going to plug in the 3. Oh, why don't I just delete all of it? That's a great idea. I'm going to plug in the 3 instead of the x, and so g of 3 is going to equal 9. So now back over to my original problem, I'm going to substitute in right here. If g of 3 equals 9, then that means what I really have is f of 9. Well, f of x was the x plus 1. But instead of x right here, I'm going to plug in whatever's in the parentheses. I'm going to plug in the 9. So now I've got 9 plus 1, which is 10. And that's it. That's my answer. For the next one, I'm doing something very similar. A couple people were getting thrown off by the parentheses and the brackets that are here. Really, if I write in the other notation, it's f of g of negative 2. Really, all those parentheses can be counted for as just part of the notation. And now, again, I'm going to start on the inside with the g of negative 2. So g of negative 2, well, g of x was the x squared, but instead of x, right here, I'm going to plug in the negative 2. So I plug in the negative 2, so I find out the g of negative 2 equals a positive 4. So now back over here, I'm going to substitute in. This is equal to positive 4, so now I have f of, well, g of negative 2 is a 4, so I plug a 4 in for it. So now look at what I've got inside of here. I've got f of 4. I'm going to take it off to the side. F of 4 equals, let's see, f of x is x plus 1. But instead of x here, I'm going to plug in a 4. So I find out that that equals 5. So right here, I substitute back in. That's equal to 5. So now what I really have is f of 5. For my last step, f of x was x plus 1. Instead of x, I plug in a 5. So now I find out that my answer is 6. Plug it in, I get a 6, and that's it. Okay, that's all there is to it. And again, I like taking the work off to the side, keeping it separate, and then plugging it back in. For the next one, it says to find f of g of h of x. Okay, and again, we're going to kind of just treat the parentheses, just help us get the notation down. Really what this means is f of g of h of x. And now I'm just going to plug each of these in. So I'm going to start on the inside with the h of x. Well, h of x is the 4x. So I plug a 4x in its place. All right, now I look at what's on the inside. I've got g of 4x. I'm going to take that off to the side. G of 4x, it's an ugly looking 4, Mr. Jansen. Let's try that one more time. 4x, remember g of x is 3x plus 1. But instead of x, I'm going to plug in whatever's in the parentheses, the 4x. So now it simplifies to 12x plus 1. So coming back over here, I've got f of 12x plus 1 because that's what g of 4x was. And now I take my f of x function. My f of x function was x squared. But instead of x right here, I'm going to plug in the 12x plus 1. So now I have 12x plus 1 squared. And remember when I do that, 12x plus 1 squared is the same thing as 12x plus 1 times 12x plus 1. So I've got a FOIL or distribute here. And when I do that, I find out that this is going to equal 144x squared plus 24x plus 1. And that's it. That's all there is to it. Okay? So be aware of that. Start on the inside, plug one function into the other, and then plug that new answer into the last function. All right?